All right, it's Tuesday, I would imagine, and we're looking at a situation where we had this is a practice problem. You had the answers for OYOs 1 and 2, so you had to do practice problem number 1, where there was a concave spherical mirror. The object was at 3.5, so 1, 2, 3.5. Here's my object. The radius of curvature is 5. 1, 2, 3, 4, 5. So 2.5, it puts the focus about there. So, did you take the first ray and come in from the top of the object horizontally and reflect back through the radius? Through the focus. And did you take the second ray through the focus and reflect horizontally? And did you take the third ray from the object to the radius? And since the radius is behind, we have to grab the radius first, then hit the mirror, and it reflects back through the same spot. So if I'd drawn that real accurately, they would intersect right there. So the object is inverted, magnified, and real. So hopefully that worked for you. And let me look at the next one, number 2. Well, number 2, the object is 3 centimeters away. And the radius of curvature is 10. So I'll grab the focus. And we have the radius out here. All right, following the 3 rules, in horizontal, out through the focus, and in through the focus, out horizontal. Oh my, so slanted, sorry. So where's my reflected ray? The first one went in horizontal, and this is the darker. And the last ray tracing step went in from the top, went through the radius to the top, and back through the same. So notice those 3 dark arrows aren't going to intersect in front of the mirror, so did you take them in back, extrapolate, and find that they intersect back here. So drawing the image the way we do, oops, we don't do it that way. This is the top of the image and this is the bottom of the image. So here is the results. So we have upright, this is number 2 practice problems, upright, enlarged, and this is virtual because we used extrapolated rays to get it. All right, hopefully you are seeing some success on that. We're going to go on and do 2 examples this time for a convex mirror. So you will see that all the principles work the same, but there's a little twist here and there. So this time the mirror is going to bend the other way. So this is the reflective part of the mirror. And the object is going to be in front of that reflective surface. So you're going to draw in your axis, optical axis again. And let's say this first one, we're going to put the object at 6. 1, 2, 3, 4, 5, 6. And we are going to have a radius of curvature of 8. Now that's where we start to do things differently for the convex. So this is convex spherical mirror. All right, because it's curving this way, the circle is this way if I was going to complete it. So the radius would make sense to be over here because the circle is here. So the radius on this one is 4. So it has to be on the other side from the object. If this is the radius, still the focus is halfway to the mirror. But notice it's on the non-reflective side of the mirror. So how does that hinder us or help us? It changes things. So the rules will be the same. So the first ray will come in from the top of the object horizontally. And when it hits the surface, a reflective surface, it's got to reflect at that point. It can't really go through the mirror. So we have, if you've looked on the other side of the mirror, it's usually painted and an opaque surface where it cannot pass through it. So it's going to reflect at this point. Let me get this out of the way. Because that is a reflective surface, it's going to hit at that point, and the rule says it reflects back through the focus, but there's no focus on this side, so we're going to have to line it up with the focus on this side. So in horizontally, back through the focus, but it can't go through that, so we extrapolate, but we grab the angle from this extrapolated ray that does hit the focus, and so the reflection will go like that, as if it came from the focus on the other side. So this is the reflected ray in horizontally back through the focus. But the focus, when I say back through the focus, part of it is extrapolated behind that mirror. All right, so the second rule is you're going to go in through the focus. So I'm going to head from the top of the object straight through the focus. So as I do that, I am impeded by the mirror. Can't pass through the mirror, so it's as if it's going to the focus. So I extrapolate there. But at this point, it's going to reflect back horizontally, as that rule says. So my darker arrows are the reflective parts, which are the ones I'm interested in. So recap so far. In horizontally, back through as if it went through the focus, and in through as if it went to the focus, back horizontally. All right, so the third rule is in as if it's going to the radius. So it's going to head from the top to as if it's going straight through the radius, and it's going to reflect back exactly on that line. So these three dark arrows never will intersect on this side. So we extrapolate backwards and we see they intersect about right there. And so the object is inverted. It is greatly reduced. And it is virtual. All right. All right, so hopefully that made sense, those changes. Why don't you try another one and turn off the video and try this one, and we'll turn it back on and see if you got it. This one will have the object is at 2 centimeters. It's concave spherical mirror, and the radius is 4. So let's see what that happens. What happens with that? The object is 2 centimeters in front of a convex spherical mirror, and the radius of curvature is 4. So do some ray tracing and find the image and turn it back on and see if you got it correctly. All right, I'm going to keep going here. Here is the optical radius. The object is 2 centimeters in front, and the radius is 4. And the focus is 2. So that's behind the mirror, the reflective surface of the mirror, behind this where it's the non-reflective surface. All right, so did you come in horizontally and go out as if it went through the focus? So at this point, the reflection will follow this path as if it was going through the focus. Then in as if it's going to the focus, it'll start straight through the focus and come out from this point where it hit the mirror horizontal. And the last one goes in from the top of the object as if it's going to the radius. So it'll go in and then it can't pass through that mirror, but it will reflect back through that same path. So those three will intersect back here somewhere, about right there. And you get reduced, reduced, inverted, and virtual. Reduced, inverted, and virtual. So did you get it right? All right, hope so. Let's see, for your assignment today, you may look at Mod 12, Optics, and it probably is OYO 12.3. Let me see where it is. Yes, 12.3. And in the practice problems in the back, I'm looking, it's probably number 3. It is number 3. All right, so only 2. They only gave us 2 to do. So OYO 12.3 and practice problem number 3. And that's your classwork for today. If you would keep those in your notebook, I want to see the results when I get back. And if there's extra time, which I assume there will be, you may work on your review questions. If you are stuck on one, just go ahead and do one that you can do, and we'll fill in the holes together. And if you need this there after review number 1, it goes to review number 2. Unfortunately, I didn't leave any behind. So if you need those problems and you finished one and you need to go on to review paper 2, I'll just sit with someone who has that paper and write out the problems on a separate sheet. All right, that'll keep you going and making forward progress in my absence. All right, till tomorrow's video, over and out from the Happy Grandmom. Goodbye.